Okay, math students, today we're going to talk about similarity, dilations, and enlargements. But before we get started, we're going to do this warm-up. So I'm going to hit pause and then go ahead and start. Okay, so these are vertical angles. And so because they're vertical angles, I can make them equal to each other. So 2 plus 3x equals 62. These are going to be equal because they're across from each other. They're vertical angles. Okay, so vertical angles are equal. So first step is subtract 2 on both sides of the equal sign to make that go away. So now I've got 3x equals 60. And then the next step, we divide both sides of the equal sign by 3. And then we get x equals 20. All right, let's do the next question. You're going to have a lot of problems like this in the similarity assignment. So we have to do distributive property with the 6, and then we get negative 36 equals 12 minus, and then 6 times 8 is 48. And then the next step is we can subtract 12 on both sides, and then that makes that go away. And then I get negative 48 equals negative 48n. Well, that's very convenient because I can divide both sides by negative 48. And then I get n equals 1. Now, I could have done it another way. Another way would have been, let's rewrite the question. If you had noticed that 6 goes into 36 6 times, so I could have divided both sides by 6, and if I had done that, then this would have canceled out. And then I have negative 36 divided by 6 is negative 6 equals 2 minus 8n. And then I could say, okay, let's subtract 2 on both sides to make that go away. And then negative 6 and negative 2 gives me negative 8 equals negative 8n. And then if we divide both sides by negative 8, then we end up with n equals 1 also. Okay, so now we're going to do a dilation. I'm going to show you how dilations work. So the first thing I'm going to do, so a dilation is when a shape changes size, but the shape is going to stay the size. So when you've got a dilation, you can have a point of dilation. And what I'm going to do is I'm going to draw some lines and go through each of the points on this triangle. So I'm going to just lightly draw some lines, very lightly draw these lines. And they go through the corners, the points of the triangle. I'm going to go through that point there. Okay, and now what I'm going to do is I'm going to measure the length from here to here. So from here to here I've got an inch, so I'm going to go that same distance out because I want to make a dilation twice the size. So if I go from here to here, it looks like it's about an inch and 3/8. So I'm going to go about an inch and 3/8 again. And then from here to here, it looks like it's 7/8 of an inch. So I'm going to go 7/8 of an inch again. And now I can connect the lines. And now I have a triangle that is literally twice the size of the green triangle. And now I've created a dilation. Okay. So, same thing. If I want to get a triangle twice as big, let's just do the one 3 times as big so we can get through the notes. So I measured this length here, and it's 1/2 inch. So if I'm going to make it 3 times bigger, I'm going to have it go 1/2 inch 3 times. Okay. Now, this here is a whole inch, and I'm calling that 2 units. So if I multiply that, so if I'm going to go, so this here is a whole inch, and I'm going to make that 3 times larger. So I'm going to go a whole inch, another whole inch, and another whole inch. And this is an inch, so I'm going to go 3 times over as well. Okay, and then I can connect these lines from there to there. And you can see that this shape is exactly the same size, except 2 times bigger. You know, let's do the other one while we're at it. Okay, so this is 1/2 inch, so I'm going to go a whole inch. Okay, this is an inch, so I'm going to go 2 inches. I'm going to go 2 inches here. And then I'm going to connect them. So let's just label the lengths here. So this was 2. If I'm doubling that, that's going 4. And this is going 4. And this is going 2. And if I'm doubling this length here, if that's 2 and that's 4, this is going to be a length of 6 units. And this is a length of 6 units also. Okay. This is twice as big. This is 3 times as big. Okay, now we have to practice some proportion practice. So if I've got 10 over m equals 5 over 11, I could notice that this is twice as big. The 10 is twice as big as the 5, so this is going to be twice as big as that. M is going to be equal to 12. But let's pretend I didn't see that so carefully or quickly. I could have said 10 over m equals 5 over 11. You should be able to think, okay, we can cross multiply, and we can say that m times 5 equals, m times 5 equals 10 times 11. And then I could multiply this out, but I could say, okay, look, 5 goes into 10 twice. So then I have m equals 2 times 11, and then we end up with m equals 22. Okay, the next one is not going to be quite so straightforward, and you have to use a calculator. So if these are similar shapes, then the ratio of this side here and this side here should be equal, and the ratio of this side here and this side here should be equal. So let's set up our ratios. So I can say that 8 over 20 should be equal to 6 over x. Okay, and then this is not as simple as this one, so we're going to have to cross multiply. So we're going to have to say that x times 8, or 8 times x, is equal to 6 times 20 when we cross multiply. Okay, so now I'm going to get my calculator. Okay, well, 6 times 20 is 120, so I have 8x equals 120, and if I do 120 divided by 8, we get 15. So if we divide both sides by 8, we get x equals 15. Okay. Make sure you hit pause if you need extra time to write things down. Oh my gosh, we've got more to do. Are these triangles similar? Okay, so you need to set up the ratios. The smallest side here is 6. The smallest side here is 3. The longest side is 10. The longest side here is 5. And this one would have to be congruent to this one. So if I set up the ratios, we've got 6 over 3, you know that's equal to 2. We've got 10 over 5, we know that's equal to 2 if I simplify it. But if I look at 7 over 4, that is not equal to 2. Therefore, they are not similar. Okay, let's do the next one. Okay, these figures are similar, so let's figure out to solve for y and for x. So the similar sides here are 8 and 24. Okay, so I can create a ratio of 8 over 24, and that should be equal to the other ratio of y over 18. And we can cross multiply and solve for y. I'll do that in just a minute. Let's set up the other ratio. We have 8 over 24, the ratio of the yellow sides, right? And let's set up the ratio. I'm going to make these ones pink because those are similar. So if I have 8 over 24, I'm going to have 11 over x. Okay, and once again, we're going to cross multiply and solve for the variables. So now 8 goes into 24 3 times. So I could say 8 over 24 equals 1/3, because 8 goes into 24 3 times. So we can say 1/3 equals y over 18. So I could say 3 times y equals 1 times 18 if I am cross multiplying. And then if I divide both sides by 3, then I get that y equals 6. Okay, now over here, if I cross multiply, we could get 8x equals 24 times 11. And as I said before, 8 goes into 24 3 times. So then I have x equals 3 times 11. So x equals 33. If you have trouble with this question, you may want to pause and rewind and listen to this one again, or ask me during office hours for extra help. Okay, last one. Last page. Okay, find the perimeter. Okay, perimeter is when you add all the sides around. So this is 7, this here is also 7. If this is 3, this here is also 3. So for the perimeter, it's 3 plus 3 plus 7 plus 7, which is equal to 14, and 6 is 20. Okay, now the area is length times width, so 7 times 3, which is 21 units squared. This is units. Okay, now what if it's increased by a zoom factor of 2? Well, then this new length here is going to be 14, and this new length here is going to be 6. So the perimeter is, okay, so then this is also 14, and this is also 6. So the perimeter is going to be 14 plus 6 plus 14 plus 6, and we get 40. And the area is equal to length times width, so 14 times 6, which is equal to 84. Okay, so the question is the perimeter doubled? Okay, so we went from 20 to 40. Yes, it is doubled. Is the area doubled? Okay, is 21 times 2 equal 48? The answer is no. Okay, now why is it not doubled? It's because the length, the reason is because the length was doubled and the width was doubled. So when you multiply a doubled length and a doubled width, you're going to end up with 4 times larger. And let's see if that's correct. Is 21 times 4 equal to 84? Yes, it is. Good luck doing your notes. And hit pause and rewind if you need to.